Assalamu alaikum students. How are you? We begin this chapter number 1 of quadratic equations from question number 1, in which we are required to write the following quadratic equations in the standard form and point out a pure quadratic equation. It means we have to solve these given equations and find out whether these are in standard form of quadratic equation or pure quadratic equations. So let's begin with the part 1, in which two expressions are in a product form. We use the simple method of multiplication, in which x is multiplied first by x minus 3 and plus 7 is multiplied to x minus 3. X multiplied to x, we have x square. X multiplied to minus 3, we have minus 3x plus 7 multiplied to x, 7x, 7 3s are 21, but plus minus minus, so we have 21 over here, minus 7. Now, x square, like terms having different sign, we do subtraction. 7 minus 3 plus 4x minus 21, minus 7 is taken to the left hand side, becomes plus 7 is equal to 0, and 0 is left on the right hand side. X square plus 4x minus 14 is equal to 0, and we observe that that is the same form of the standard quadratic equation. Hence we can say that thus the above equation is a standard form of quadratic equation. Let's move to the part 2, in which we are given a rational expression on the left hand sides. You're familiar about the basic idea of finding the solution of such expressions. Actually, we take the LCM of the denominators and multiply by the each term. So let's do it. 3, 7, as they are uncommon factors, so therefore we find that LCM equal to 21. 3 7 is 21, so 21 is multiplied to the each term. 21 multiply x square plus 4 over 3 minus 21 is multiplied to x over 7, and 21 is multiplied to 1, and what we get, 3 1s are 3 and 3 7s are 21. 7 1s are 7, 3s are 21. 7 is now multiplied to x square plus 4 minus 3 is multiplied to x, and we have 21 1s are 21. Now we open the bracket. 7 x square plus 28 minus 3x is equal to 21. 7 x square, we rearrange these values. 7x square minus 3x plus 28, 21 is taken to the left hand side, what we get, minus 121 plus will become minus, and 0 is left as 21 is taken to the left hand side. 7x square minus 3x, 28 minus 21 will be equal to plus 7, as like terms having different signs, we do subtraction. So 28 minus 21, we get 7 equal to 0. Thus the above equation is a standard form of quadratic equation. Let's do part 3 to point out whether the given equation is a standard form of quadratic equation or a pure quadratic equation, in which we have rational expressions on our hand in the left hand side. So again we use the same phenomena. We take LCM of the denominator and multiply by the each term. x plus 1 and x are uncommon factors, so therefore we multiply their product to the each term. X into x plus 1 is multiplied to x over x plus 1. Second term, plus x into x plus 1 is multiplied to x plus 1 divided by x, equal to x into x plus 1 is multiplied to 6. In the next step, x plus 1 is cancelled by x plus 1 and x is multiplied to x. Whereas in second term, x is cancelled by x and x plus 1 is multiplied to x plus 1. 6 is multiplied to x and x plus 1 we multiply in the next step. X into x, basis same powers are added, so x raised to power 2. We use the simple method of multiplication. X first multiplied to x plus 1 and then plus 1 is multiplied to x plus 1. 6x is multiplied to x, that will become 6x square. X and x bases are same, the powers are added, so 1 plus 1 2. 6x 1s are 6x. The next step, x square plus x into x square, x into 1, x, 1 into x, x, and 1 into 1, 1, equal to 6x square plus 6x. Like terms, their coefficients are added as their signs are same. So 1 plus 1, 2x square plus 2x plus 1. We take these values to the left hand side. So 6x square will become minus 6x square, whereas 6x will become minus 6x, equal to 0 is left on the right hand side as both the values are taken to the left hand side. 2x square minus 6x square will be equal to minus 4x square. As like terms have different signs, we do subtraction. So in the next 2x minus 6x will be equal to minus 4x plus 1 is equal to 0. We use a standard procedure to make the first term positive. We take minus as common, so it will become 4x square and minus will become plus 4x, plus will become minus when we take minus 1 as common. Minus 1 is taken to the right hand side. 0 divided by minus 1 will remain 0. So therefore 4x square plus 4x minus 1 is equal to 0. Thus the above equation is a standard quadratic equation. Now we move to the part 4, in which we have to deal with this equation, in which we use the same procedure as we used in the previous questions. We take the LCM of the denominator, which is x into x minus 2, and that is multiplied. X into x minus 2 is multiplied to the first term, x plus 4 over x minus 2 minus x into x minus 2, the LCM of the denominator is multiplied to the second term, x minus 2 over x, and again x into x minus 2 is multiplied to the third term, which is 4, equal to 0. And 0 when multiplied to any number, it makes it 0. So therefore we do not write the value on the right hand side for multiplication. Before moving to the next step, we observe that x minus 2 is cancelled by x minus 2, x is cancelled by x. X is multiplied to x plus 4 minus x minus 2 is multiplied to x minus 2 plus x the linear factor is multiplied to 4, that will be 4x into x minus 2 is equal to 0. In the next step, x is multiplied to x. This is the same, the powers are added, x square, x into 4 will be 4x. As minus sign is present before the product, therefore we put a square bracket to avoid the mistake. We use the simple method of linear product. X into x minus 2, minus 2 is multiplied, second term multiplied to the x minus 2, plus 4x into x, that will be 4x square, plus minus minus 4 2s are 8x, number is multiplied to the number, equal to 0. In the next step, x square plus 4x minus, we do the internal part of the bracket according to the Wiedemann rule, x into x, x square, plus minus minus 2x, minus plus minus 2x, minus minus plus 2 to the 4, plus 4x square minus 8x is equal to 0. X square plus 4x minus, we open the bracket, minus x square, minus is multiplied to minus plus 2x, minus is multiplied to the minus plus 2x, minus plus minus 4, plus 4x square minus 8x is equal to 0. Before moving to the next step, we observe that like terms having same signs, they are cancelled. 4x square, according to the descending order, we write 4x square as a first term, 4x plus 2x plus 2x, signs are same, like terms, we do addition, 4 plus 2, 6 plus 2, 8, 8x minus 8x, and rest of the value is minus 4, we write over here. Like terms having different signs, they are cancelled and the value is left, that is 4x square minus 4. In the introductory lecture of this chapter, Quadratic Equations, we learn the basic form of pure quadratic equation is ax square plus c is equal to 0. Mean, if quadratic term and a constant term is left in an equation, then that will be a pure quadratic equation. Thus, the above equation is a pure quadratic equation of the form ax square plus c is equal to 0. Students, let's do part 5 of the question number 1, exercise 1.1. In this again, we are to identify whether this given equation is a pure quadratic equation or a standard form of quadratic equation. So let's do it. We take the LCM of the denominator, x plus 4 into x, these are uncommon factors, so therefore what we do, we multiply each term by their product. X into x plus 4 is multiplied to the first term, x plus 3 divided by x plus 4, minus x into x plus 4, the LCM is multiplied to the next term, x minus 5 divided by x, x into x plus 4 is multiplied to 1, the right hand side. Before moving to the next step, we observe that x plus 4 is cancelled with x plus 4, and now we take x into x plus 3 to the next step, minus x is cancelled to the x, and x plus 4 is multiplied to x minus 5. 1 is multiplied with the linear factor 1x, so it will remain x into x plus 4. In the next step, x is multiplied with x, x square, x into 3 will be 3x, minus, and we put a square bracket, as we discussed earlier in the previous part, that if we have minus before the product, we put a square bracket to avoid the mistake, and we use a simple method of linear product. x is multiplied to x minus 5 plus 4 is multiplied to the x minus 5 is equal to x into x square, and x into 4, 4x. X square plus 3x minus x into x square minus plus minus minus 5 ones are 5x plus 4 ones are 4x plus minus minus 4 5s are 20 is equal to x square plus 4x. X square plus 3x minus x square, all the signs are changed, minus minus plus 5x minus plus minus 4x minus minus plus 20 is equal to x square plus 4x. Like terms having different signs are cancelled in the same step, and 3x plus 5x like terms, we do addition, 8x minus 4x plus 20 is equal to x square plus 4x. We take this x square plus 4x to the left hand side, and that will become minus x square minus 4x plus 8x minus 4x plus 20 is equal to 0. Minus x square remains the same. Minus 4x. Like terms having same sign, we do addition. So minus 8x we have plus 20 is equal to 0. Like terms having different signs are cancelled, but we left minus x square plus 20 is equal to 0. We take minus common as a standard procedure to make the first term positive. X square minus 20 is equal to 0. X square minus 20, minus 1 is taken to the right hand side. 0 divided by minus 1 will be equal to 0. So we observe that is a pure form of quadratic equation, as it is in the form of ax square plus c is equal to 0. So thus the above equation is a pure quadratic equation of the form ax square plus c is equal to 0. Let's do the part 6, in which we are required to point out whether this equation is a pure quadratic equation or standard form of quadratic equation. So we use a different technique as discussed in the previous 5 parts. So that is, we take the LCM of the left hand side like this. X plus 2, x plus 3 are non-common factors. So we write the LCM as same, x plus 2, x plus 3 equal to 25 over 12. As we know the simple procedure of LCM, LCM is divided by the first denominator x plus 2. LCM x plus 2 into x plus 3 is divided by the first denominator x plus 2. X plus 2 is cancelled by x plus 2. X plus 3, that value which is left, that is multiplied to the numerator. X plus 3 into x plus 1. Now we divide this LCM by the second denominator. X plus 2 into x plus 3 divided by x plus 3. X plus 3 is cancelled and x plus 2 is left, and that is multiplied to the numerator, second numerator. X plus 2, the quotient, is multiplied to x plus 2. In the next step, we multiply directly. First we multiply x to x. We have x square. X is multiplied to 1. We have x. Now what we do in the next, we multiply 3 to x and we get what? 3x. plus 3 ones are 3 we have. For the next part, plus x is multiplied to x, we have x square. X is multiplied to 2, 2x, 2 ones are 2x, 2 twos are 4. In denominator, we do the same. X is multiplied to x, x square. X is multiplied to 3, 3x. 2 ones are 2x, 2 threes are 6, equal to 25 over 12. Like terms are added as the signs are same. 1 plus 1, 2x square. X plus 3x, 4x, plus 2x, 6x, plus 2x, 8x. We have in the numerator. 3 plus 4, 7. In denominator, we have x square plus 3 twos are 5x plus 6 is equal to 25 over 12. According to cross multiplication, twelve is multiplied to 2x square plus 8x plus 7, and 25 is multiplied to x square plus 5x plus 6. Like 12 is multiplied to this expression and 25 is multiplied to this expression. Now we simplify these. 12 twos are 24x square. 12 eights are 96x. 12 sevens are 84 is equal to 25 ones are 25x square. 25 fives are 125x. 25 6 are 150. Now we take all these values to the left hand side and we get 24x square plus 96x plus 84 minus 25x square minus 125x minus 150 is equal to 0. As these values move to the left hand side, so all the positive values will become negative. 24x square minus 25x square. Like terms having different sign, we do subtraction. Minus x square, we have 96x minus 125x equal to minus 29x. 84 minus 150 is equal to minus 66 equal to 0. We take minus common, as by the standard procedure we have to make the first term positive. X square plus 29x plus 66 is equal to 0. Minus 1 is taken to the right hand side, becomes x square plus 29x plus 66. Minus 1 when taken to the right hand side, 0 divided by minus 1 will be 0. And now we have a standard quadratic equation on our hand. So thus the above equation is a standard quadratic equation That's it for the question number 1, in which we point out the given equations are pure quadratic equations or standard form of quadratic equations. Thank you.